Welcome learners to today's lesson of exponents and scientific notation, where today we are going to be focusing on the practice and application questions. Let's get to it. So let's remind ourselves of law number 5, where we have a negative exponent. So we have here 5 to the exponent negative 2. Do you remember what happens when we have a negative exponent? So it is going to become a denominator or a fraction actually, and that is going to be 1 divided by 5 squared. So now the exponent is positive, and our answer there, we know that 5 squared is 25. This means that our answer to 5 to the exponent negative 2 is 1 divided by 25. Our next example there, we have 2 multiplied by 3 to the exponent negative 3. So what is going to happen here? The one that has the negative exponent is the base 3. So that whole power will become a denominator. So that means we are going to have 2 divided by 3 to the exponent 3. And what is 3 to the exponent 3? Yes, you are correct. Our answer there is going to be 27. So if you had that answer, good for you. So we have here number 3. 1 divided by 4 to the exponent of negative 3. So what is going to happen here? The negative exponent is already in the denominator. So it is going to become a numerator, and it is going to multiply with whatever numerator is there already. So this is going to give us 1 multiplied by 4. Now we have a positive exponent, and that is a positive 3. That now gives us 1 multiplied by, what is 4 to the exponent 3? Yes, you are correct. It is 64. This means that our answer is going to be 64 because 1 multiplied by any number is itself. Then we are going to have 7 to the exponent negative 2. So now what is going to happen to that negative exponent? We are going to change it to a fraction, and it is going to be 1 divided by 7 squared. Now our exponent is positive. And what is 7 squared? That is 49. So our answer is going to be 1 divided by 49. Our next reminder is when we have a exponent 0. So when we have a base that is raised to an exponent 0, do you remember what happens to it? Yes, you are absolutely correct. That number will change to 1. So a number to the exponent 0 is equals to 1. Our next example, we have a product, and that product is raised to the exponent 0. You can do this question using our different exponential laws. Remember, when we have a product that is raised to an exponent, each factor will get that exponent. But because any number raised to the exponent 0 is 1, we have there 1 multiplied by 1, and that will give us an answer of 1. What about if we have a missing number or an unknown number? So I have there 1 divided by 25 is equals to 5 to the exponent of something. We can just place a placeholder, we can just put a variable just to represent that number that we do not know. So let us use y. Remember, you can use any letter to represent an unknown number. If I change 1 divided by 25 to an exponential form, that is 1 divided by 5 squared. And I have 5 to the exponent of y, our unknown. What is going to happen if I want to bring that power to the numerator? That means that our exponent is going to be negative. But now my base is the same. And what happens when my base is the same? Then it means that I can simply say that therefore my two exponents are also equal because these two powers are equal to each other and the base is the same. So that means that negative 2 is equals to y, or y is equals to negative 2. Our next one, we have 32 is equals to 2 to the exponent of something. What letter do you want to use here? You can use any letter. I am going to use T. So what is 32 in exponential form? Do you remember? So 32 is 2 to the exponent 5. And that is equals to 2 to the exponent T. And because the powers are equal to each other and the base is the same, this means that our exponents are also the same. So therefore, 5 is equals to T, or T is equals to 5. Let's remind ourselves of how to write numbers in scientific notation. I hope you remember how to do that. Let's look at this first example. So we have there 34,210,000,000. And how can we write that big number in scientific notation so that it's easier for us to write? So remember, we are going to be moving the 3, which is in the 10 billions position. And we need to move it all the way to the ones position. So, firstly, I am going to write 3,421. Because remember, when we are writing in scientific notation, I need to make sure that my decimal is either equal or greater than 1, but smaller than 10. And we always write our scientific notation as a product of two numbers, and the second number will be, or the second factor will be a 10 raised to an exponent. For us to figure out which exponent it will be, or what exponent it will be, we need to see how many times we are shifting that 3, which again is in the 10 billions position, and we are shifting it to the ones. And also the direction that we are shifting is very important as well. We are moving to the right. And remember, moving to the right means positive. So let's move it. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have moved our 30 billion 10 spaces to the right. So that means we are going to have an exponent of a positive 10. Let's look at the next example. So our next example there is 0,006789. We are looking at the first number that is not a 0, and that's the number we are going to shift to the ones position. So we are going to say here that our first factor is going to be 6,789. We know that we are going to multiply that by 10, but our exponent has to be determined by how many times we are going to shift that number. So that is 1, 2, 3, and we are in the ones position. So that is going to be a -3, and remember, it is a -3 because we are shifting to the left. And then our last example there is going to be 134,56. Now, you might think that this is already in a decimal form, but remember, our number needs to be between 1 and 10, or it needs to be equals to 1 or greater than 1 and smaller than 10. So that means we need to move that 100 to the ones position. So this means that we are going to have 1,3456. And we are going to multiply that by 10. Then we are going to check which direction we are moving that 100 to get to the ones position. So that is 1, 2. We have moved it 2 times to the right. Right means positive. So that is a positive 2. Let's quickly go to an ad break, and then we'll see you just now to continue with our work.